Hey everybody, welcome back to the Print3D channel. The October MakerBox has arrived. We're going to open it up, check out some cool new filaments, and print out some cool stuff, and I'm going to share my results with you guys, so stick around. Hey everybody, welcome back, and thank you for joining me here on the Print3D channel. Like I was saying in the introduction, the October MakerBox has arrived, and this is one of my favorite parts of the month when I get to test and review all kinds of cool new filaments. And the MakerBox never disappoints. So let's not waste any time. Let's go ahead and get this box open and see what kind of filament we have for this month. Again, this is the October box, and I'm not sure if this is the Explorer or one of the other packages because they randomly send me a different box every month. So this month it could be 4 filaments, it could be 5, it could be 4 with a bonus. The box feels pretty heavy, so I'm not sure what's inside. So let's go ahead and cut it open and see what we got. And of course, a huge shout out to MakerBox for sending over the monthly MakerBox subscription service for us to test and review on the channel. So let's go ahead and open it up and see what we have inside. Ooh, right off the bat, Earth 2019 sticker. That's awesome. I'm definitely going to add this to my sticker wall once it goes back up. Very cool. Some original Skittles. A card introducing Filastruder, and it's a filament company. We sell Voracity, ABS, PLA, Pro PLA, PETG spools, and Master Spool refills. Oh, okay, cool. So Master Spool. I'm going to be printing that new version that I saw, but there you can check that out. There's the back. Very cool. Oh, and there's obviously, that should have been an indicator that we are going to get some filament from them. So we might have 5 in here this month. So the first one I'm looking at is the Voracity Pro PLA in green. This is a really nice glossy filament. It's very cool. So let's check out the information on here. It says the hot end temperature is 190 to 230. The bed temperature is room to 60 C. Speed is not provided by the manufacturer, of course, cooling because it is PLA. And the info says Pro PLA takes the good qualities of PLA and improves the temperature resistance and impact resistance through post-print annealing. So it's annealable. Our filament is made in the USA from only raw virgin pellets. Triple axis diameter measurements are taken on production line and shared with you so you know exactly what you're getting. So yeah, filastruder.com. So let me cover up that QR code so you guys can see the package. And then let's take a look at the filament. And that's a very cool green color. I'm definitely interested in printing with this. And if it can be annealed, it's a Pro series, Pro PLA, meaning it has some professional applications for it. This will be a fun filament to test. So this is our first pack. Next up, we have some PETG Natural from GreenGate3D. I've never heard of these guys. It's natural color PETG. I've had a lot of success printing with PETG, so this should be a really fun one. Let's talk about the specifics on the package. The hot end temperature is 205 to 245, which is an average temperature range for your PETGs. Bed temperature is room to 90. I've had success with both heated beds and non-heated beds. Speed is none or low, which usually means they don't have a recommended speed, but obviously low since this is a natural. This might be fun to print out some clear stuff. Cooling 25 to 80 millimeters. I think they have that reversed on here. The cooling none to low and the speed 25 to 80 millimeters per second, and then under other it says none. So let me read you the information about this and then I'll show you the filament. It's a USA made PETG from 100% recycled filaments. Everything we extrude in top filament is from recycled plastics and exclusively made in the USA. Even the spools and pigments are American. Interesting. Our PETG prints are lower temperature than virgin resin, offering more users the chance to enjoy our filament. Our clarity is unmatched. We offer precision tolerance and generous flexibility. Recycle the world's plastic one filament at a time. Interesting. So GreenGate3D.com. This is their PETG. Let me cover up that QR code so you guys can see the filament, or the front of the package, I should say. And of course it is natural, so you'll just be able to see it. It is a nice clear color, so it's a very, very good natural. So there's our second PETG Natural from GreenGate3D. Next up we have some eSun Filament. This is their eSilk, and it's Jacinth, I guess is the color name. Interesting. It's very much like a metallic-y looking filament from eSun. And let me read you the specifics on the package. The hot end temperature is 190 to 220. Bed temperature is room to 80 C. Speed is not listed by the manufacturer. Cooling is low or none. The information here says the eSilk PLA is similar to PLA filament with good mechanical properties and good toughness. It is environmentally friendly and non-toxic compared with the traditional PLA. The silk high gloss material has a bright silky luster. Silk highlight PLA printing materials. Typical information. So it says it can be used in outdoor decorations, but I definitely recommend using caution with any kind of PLA in the hot sun. But this is a very cool color. It's very much a metallic color. eSilk. I don't think I've ever printed with anything like this before. I've used their filaments before, and it's esun3d.net. Let me cover up that QR code so you guys can see the front of the package. And let's get a shot of the back. And let me see if I can move this around so you guys can actually see that this is a very metallic and shiny filament. This will be a fun one to print with. I've been experimenting with some of these shiny or metallic filaments recently, and I really like the look that I'm getting. So this is the eSilk Jacinth. It's a really cool filament. And okay, yeah, we do have 4 packs. This is, package is faded a little bit. It's their nylon 645 black from Taulman 3D. Okay, so the hot end temperature says 250 to 255, the bed temperature 45, speed up to 75 millimeters per second, slower equals stronger, and the fan on, or no, I'm sorry, the fan says no. And it says print on glue stick, Gecko-Tech, or Garolite. It says nylon 645 is a material for demanding application, is tensile strength equivalent to unfilled nylon 6.6 with a slightly lower HDT. Nylon 645 is currently being used by the CNC shops around the world to support quick turn prototypes for pre-pilot pilot runs, as well as some limited production runs. The nylon 645 has the highest chemical resistance of all the Taulman nylons, and when annealed, is highly compatible with nylon 6.6 as required. In thin structures, the black may appear dark blue. Taulman selects a different colorant than the standard carbon black to optimize strength. So apparently something with the colorant might weaken filament. I've never heard of that before. I'm really excited about this. It looks really cool. The temperatures are all in the range, and I have plenty of print surfaces I can use for this type of filament. Let me cover up the QR code so you can see how I'm struggling to read the front of this package. It's very sun faded, or just faded in general. Maybe the inkjet printer was out of ink. But let's go ahead and look at the back so you guys can see the actual filament. It's got a bit of a gloss to it, so this should be a fun filament to print with. Now there is a eSun product manual for 3D printing material. It's a big catalog of all their different filaments and their applications. So that's kind of cool to have handy. And I think that's it. Yep, there we go. Box is empty. So this month we have a cool selection of new filaments. Again, it looks like I'm going to be able to use, I think half of these will go fine on the sanded acrylic bed on the G-Max, but I'm definitely going to be whipping out the heated bed and all my knowledge of using nylon for the Taulman nylon. This eSilk, this is PLA, so this should work fine on the sanded acrylic. The PET G, this definitely is going to require some bed temperature, so we are definitely going to be using that one with this. So we have 2, and we have the Voracity Pro PLA in green. So definitely I can see using the sanded acrylic bed for these, and the heated bed with the Build Tack and the Magigu Assist for these unique filaments. So this will be a fun printing. I'm going to go ahead and reset the cameras up so we can do our quick diameter bend and twist tests, which I'm going to kind of accelerate through for this month. And let's get right to printing. Currently I have the sanded acrylic bed, so it looks like we're going to be starting with the eSilk and this really cool Voracity Pro PLA in green. So bear with me while I switch things around, and we'll get started with the tests before we start printing. Okay folks, so all of our prints are done for all the filament samples for the October MakerBox, so let's go over them really quick. First of all, I'm sure you can see right off the bat, there's some stuff missing over here. I did have some issues printing the nylon filament, which had nothing to do with the filament and everything to do with me not having a heated build enclosure for my printer. But we're going to solve that problem soon because I have more filaments coming in that will require a heated build enclosure. So anyway, let's go to this side of the filaments. Let's talk about the eSilk Jacinth, I guess I'm saying that right. I'm not sure. It's from eSun, and it's one of their newer filaments, I'm guessing, because I've never seen this before. It's actually, if you follow me on social media, this is some of the most beautiful filament I've ever printed with in this category of the shiny, kind of steampunkish, copperish looking filaments. I've printed with another one that is super glossy and looks really, really cool. But this is a different color and a different tone and kind of just a different feel altogether. It's got kind of more of a silk finish, as in the name eSilk, more than a gloss finish, as in like a metal type filament. But this filament was really easy to print with. Everything was printed on the sanded acrylic except for the nylon. I did switch over to the heated bed, but we'll talk about that when we get to the nylon. But the eSilk filament from eSun, that's a whole lot of E's. We'll just call it the Jacinth filament from eSun. It was super easy to print with. We printed right on the sanded acrylic. Like I said, the temperature range is 190 to 220, and I went with 210, and then I backed it down to 205. And of course, we started with the Cali Cat, and I always like to show off the rose twist vase because it really gets great results. But my calibration item is the Cali Cat, and links for everything that we print will be down in the description as always. But the Cali Cat turned out really, really good. There was a little bit of stringing on the tail. I didn't see a whole lot of the heated squashing that goes on around the base of the head where the neck meets. And that's a really good calibration area because it's a really good overhang. And there is some bridging on the bottom, as you can see. And it turned out really good. I was happy with it. But like I said, the temperature, what I started with was 210, and I backed it down to 205. So 205 became my standard temperature for the rest of the printing with this filament. And of course, we moved on to the Rose Twist Vase by Riskable. And if you follow me on social media, you've seen this vase before. It turned out fabulous. I'm so impressed with the way this filament looks. I was kind of leery of actually printing anything else with it. I wanted to save what little bit I had left for a larger model to print with because I wanted something that would be really sturdy I could keep and then not just a test model. But of course, testing must resume. So I resumed printing files. And I printed out the MatterHackers Carabiner that's available at MatterHackers.com. And this turned out amazing. I'm going to give you guys a little boomerang here to look at in the other camera. It just has such a luster to it. It's such a cool filament. I'm super impressed with it. I'm not going to assemble another. This isn't designed to be a strong filament. It's more of a designer's filament. So I'm not going to assemble the carabiner right here on camera. I might use this carabiner at some point, but I'm just trying to show you guys the print quality of the filament. And everything turned out good. The top layers, I would say, the M is super readable. Hopefully you guys can see that in the camera there. The M is super readable, and the top layers and the edges, and there's actually the word MatterHackers is written on the edge. Hopefully you guys can see that in the camera. But it turned out nice and sharp. I can read it from a distance. And since it's a reflective orange, copperish colored filament, a lot of times anything with type in it would be hard to read, but you can actually put this at any angle and see it says MatterHackers. So as far as detail printing goes, it did a really great job on the clip part. There was no real stringing once I reduced the temperature, so it was no problem at all. I do have just a little bit of filament left, just a little bit there. And I'm probably going to print something with it at some point. But for right now, I just wanted to finish the review for you guys so you guys could see how cool this filament is. I don't print with a lot of eSun filament. This was probably my second experience. My first experience went really well. I don't think I've actually reviewed any eSun filament either. I don't remember actually. I have so many videos in the library. But this filament was super easy to print with. I highly recommend it. I printed right on a sanded acrylic bed at 205. I think I did most of the models are printed at a 0.24 millimeter layer height. And I think with the vase mode, I actually slowed it down a little bit to 40 millimeters per second instead of 45, just because I wanted to make sure that this had some really good layer adhesion. And I wanted to see what the color of the filament looked like without any problems with layers and stuff. Because if you print within vase mode, with a really silky filament, sometimes you can see a lot of the shadowing and stuff, and I wanted each of the little polygon panels to be super smooth, and that's exactly what happened. So overall, this filament is super easy to print with. The temperature range that it advertises is 190 to 220. I sat at 205 and had no problems whatsoever with minimal stringing, really good layer adhesion, and really good first layer and top layer look. So I recommend this eSilk Jacinth from eSun. Again, this is in the October MakerBox, but this is a really cool filament to play with. Moving on to the next filament, which is the green filament here, and that is the Voracity Pro PLA Green from Filastruder. And this filament was super easy to print with as well. This is actually some really nice Pro PLA. I could definitely see using that in some machine parts or parts for a printer. This Voracity Pro PLA Green is a really strong filament too. It's a Pro PLA that takes the qualities of PLA and improves through temperature resistant and impact resistant through post-process annealing. And again, I did not do any annealing on this filament. I just wanted to show you guys how easy it is to print with, the print quality, and what the models look like once they're printed. So of course we started with the Cali Cat, and that turned out really good. Super happy with the results. The temperature range here is 190 to 230, and I believe I started at 215, and I did end up back down at 205 with good layer adhesion, no problems whatsoever. But the Cali Cat turned out great even at 215. And there's a minimal stringing on the tail, which is nominal, easily fixed. But I started to print a brim on some of these models just so I can get better layer adhesion to the print bed. And I wanted to see what a brim looked like and make sure that I'm getting proper extrusion width all the way through the model. And that's a good way to do it before you even start printing the model. So we started with the brim. Again, the Cali Cat printed out fine at 215. It probably would have printed out even better at 205. Again, sanded acrylic bed. I'm not using any heat yet. The filament itself prints pretty cleanly. I didn't have any problems with under extrusion or over extrusion. So I knew it was time to move on to the rose twist vase, which was again one of my favorite models to print. And that turned out super, super clean. I really love it. It's got kind of a matte finish, printing it at 205 in vase mode. And it actually feels like it has kind of a matte finish. It doesn't have like a real smooth texture to it, which is not a fault. It's actually a highlight or a feature. And I like the way it looks, and I like the way the texturing is on it and the way it feels. Again, printed at a 0.24 millimeter layer height. So once we were done with the rose twist vase, we printed out the MatterHackers Carabiner as usual. Now this is a strength filament, so I'm definitely going to put this one together. But I'll show you guys the print. It actually turned out super clean. I didn't have any layer adhesion problems from what I could tell. The first layer printed down pretty perfectly. We're on the sanded acrylic bed, so I always get a really nice surface finish, and that looks awesome. You can read the MatterHackers logo on the side. There is a little bit of echoing going on, but I do have a G-Max 1.5 XT Plus, the printer you see behind me, and there's a lot of mass moving around, and I think I sped up the print on this one to 45 millimeters per second and turned off all the variables so it prints at exactly 45 millimeters per second for the entire print. And I believe that was the reason why we saw a little bit of ghosting or a little bit of echoing in the type there. But in general, that part turned out perfect. And these parts print together on the build plate. The link is down in the description. And it's super easy. It's like 25 to 30 minutes, depending on your print speed and what you're doing with it. But at a 0.24 millimeter layer height, I can knock these out in 30 minutes, which is a perfect test model. Now this one turned out really, really good. I'm super happy with the way the little connector pin turned out. So let's go ahead and see if I can get this together on camera. Now I've put enough of these together that I should know how this goes. And if it breaks, you guys will be able to see it. Let's make sure we do this right, because I found a way to do this better by having having the closing pin on the inside before you finish the move. That's a pretty strong little, oh, I just broke it. So you get to see it, there it is. So I probably should kick the temperature up to probably a higher temperature instead of moving down to the 205. But in general, this was a learning experience. The print themselves look good, but we do have some layer adhesion problems right there on the clasp. So kicking it up to 210, this is why we do test prints. So kicking it up to 215, I'm sorry, from 205, that's why we do the test prints. So I can tell you right now, even though the filament did run out, surprisingly, because I was able to print the same amount of models and have leftover filament, but it's a weight thing, I guess, or maybe it's a meters thing, I'm not sure. But I ran out of filament, so I didn't get to finish testing my very first printer part added to the arsenal, added to the paradigm, as I like to say. And I can tell you that obviously we're going to have some layer adhesions because you just witnessed a breakage on camera. So 215 would be the optimum temperature. But the part that did print before I ran out of filament looks great. I definitely would use this as a test print part to make sure that all my settings were dialed in. I'd definitely run some bolts and screws or whatever it needed, attach it to the motor if it needed it, or if this was for a different part of the motor shaft, or where this sits in the y-axis. I'm not actually sure, I don't have a Prusa. But I think this would be a good test print, obviously, if it finished. But at 210, at 205, there we go. So it did break. Make sure I didn't cut myself on camera, that would be kind of bad. It did break, so we definitely would be kicking this up to 215 to get proper layer adhesion. Now that's why I'm doing all this, make sure I'm not bleeding. And that's why I'm doing all this testing, is to show you guys what the best settings are for my printer. Now they may vary depending on the printer you have, but I'm giving you a good starting position. So overall, I would say the only thing we would need to change for the Voracity Pro PLA Green was to move that temperature back up to 215 and maybe increase the cooling a little bit, and maybe reduce some of that retraction, so that would reduce any problems with blobbing because we are increasing the temperature. But overall, printing it at 205 degrees, I didn't have any problems with the prints. Everything turned out good. They all look great. We did have some layer adhesion problems, but that's because I reduced the temperature from 215 to 205 because I believed it needed that to finish the testing. So overall, I would say this filament from Filastruder is actually pretty good to print with. I would definitely like to have a little bit more of it so I could finish testing and make sure that we had good layer adhesion at 215 degrees so I could show you guys that there was an improvement. But unfortunately, I don't have enough. This is a sample. We are doing just sample testing. So overall, I can recommend the Voracity Pro PLA Green based on appearance and printability. Layer strength, I would definitely need more of it to check it out. But for now, I'm pretty happy with the way things turned out. So let's go ahead and move on to the next filament, which is the PETG Natural from GreenGate3D. Now, when I usually print with PETG, I'm usually using a heated bed because that's really the best way to get a good layer adhesion and are on the first layer and make sure the prints or the parts don't warp at the end of the print. But I had the sanded acrylic. I've used PETG before to print stuff with on the sanded acrylic. I've used PETG on the sanded acrylic before, so I knew I should probably have some success. So let's start out with the Cali Cat because I had success, so I'm pretty happy about that. Here's the Cali Cat printed out. It's going to be so hard to see because it's in natural. And the reason why it's in natural is because I'll read this and I'll remind you from earlier in the video, I did mention this, that everything we extrude, the filament is from recycled scrap plastic and exclusively made in the USA. So even the pellets and the spool holders themselves, the spools, they're actually made here in the US and out of virgin plastic, it says, I think too. But all of this is recycled PLA. I don't know why I'm holding this. All of this is recycled PLA, 100% recycled PETG, excuse me. Everything in here is recycled PETG from scrap plastics. So it's in natural. It's hard to see, but the Cali Cat actually turned out really, really good. There's some minor stringing between the tail and the body, but it's something that's negligible with a small temperature adjustment, not too small, or not too big, I should say. And I think the Cali Cat turned out really good. I did have to really look at it to make sure it turned out really nice because it's in natural. Now I do see just a little bit of meltiness near the top, on the top layers. It's really tough to see on there. The brim turned out great. The extrusion width looked really clean and evenly distributed along the brim itself. So that was a good sign. The tail seems like it's pretty strong. I don't want to break it. Broke a part on camera earlier, or 2 parts on camera earlier. We have other ones here we can break. But the Cali Cat actually turned out really nice. I'm super happy with it. On to the rose twist face. So again, if you follow me on social media, you've seen this, and here it is in the video. And I can tell you, upon close inspection of it, it still looks just as good as it does on camera. Now, the camera's probably not going to do a justification because, it's just, the filament itself is being natural. It's really tough to see the detail. It's really tough to see the print quality unless I was to throw like a coat of paint on it or something like that. But looking at the rose twist face, I really love the way this looks. It's kind of shiny and sparkly in some directions of the light, and others it really does remind me of a drinking or a water bottle, and I'm curious if there's a way to make this clear. And I've seen some methods of putting isopropyl or IPA in a PETG print and rinsing out the inside, and for some reason there's a chemical reaction. I think it's PETG, but that would be really cool, is to be able to take this stuff and actually make it clear. So if you know how to do that, leave it down in the comments and let me know. But this print turned out great, the rose twist vase. So off to the MatterHackers Carabiner. And again, this print turned out awesome. I didn't see any problems with it. There's a little bit of stringing here at the opening, but it's pretty nominal. We skipped a whole part here about what temperature I'm printing this at. The temperature range is 205 to 245. I printed these out at 230 degrees on the sanded acrylic bed. So printed them out at 0.24 millimeter layer height at 40 millimeters per second. I slowed it down a little bit just to give it a chance, because again, I was worried about bed adhesion and other issues with the PETG printing in long distance. The only print that takes longer than all of these is the Prusa part, and we'll talk about that because we had a successful print there. But the MatterHackers Carabiner turned out great. I'm super happy with the way this looks. It's a super clean edges on it. I know it's tough to see, but the MatterHackers M at just the right angle. Let's see if I can show you guys in the close-up camera. The MatterHackers M looks really nice. The top layer is super clean. It's kind of hard to see, but you can actually see through and see what the infill looks like on some angles. And that looks really good, which is a bonus. Normally you don't get to see how your infill looks on a print. But the actual base of the Carabiner turned out really nice. I'm super happy with the way that looks. And the pin or latch part, it turned out really nice, and it's actually somewhat flexible. So I'm curious, we're going to put it together here in a second, if this is got the same layer adhesion issues as the Pro PLA, since I did run these out at a higher temperature. I'm hoping it doesn't. But that print turned out really clean. That part turned out really clean. There was no problems whatsoever. It stuck to the bed because, again, this is two parts sitting on the same build plate or in the same model. So you just printed it as one piece. And it turned out great. I'm super happy with the way this looks. There was no problems, no blobs, no globs, no bad layer adhesion of any kind. So I knew we were going to have successful prints, and I definitely would be ready to move on to the printer part. But before we take a look at that, let's go ahead and assemble this. Again, I should have this down pat. I don't know why it takes me so long to do it, but let's go ahead and jam these guys together. We put that in first, and then we slide it all together like that. And that puts it together perfectly. Boom, we have it. Now, that part seems pretty strong. So let's give it the test. It's not gonna break. So recycled PETG, super, super strong. Very happy with that test. So that was a good strength test because we were able to break the layer adhesion on the latch on this one, but not on this recycled PETG. So that really gives you a good idea of strength. I'm not the strongest person in the world, but I wasn't able to break this and I was able to break that. So this is some really strong filament. I'm definitely going to use this for other stuff. So I'm glad I did that strength test after I already printed this part. This is the Prusa part again. Again, this is added now to our testing. I can feel it. When I took it off the print bed, there was actually no warping. I mean, it is super, super flat. Let me put that there in the close-up camera. It was super flat. I didn't have any problems at all. We're still printing at 230 degrees. I did have the cooling on 30% or 20%. Sorry, we had the cooling on at 40% in the beginning of the prints, and then I realized it says none or low here on the package. So I dropped it down to 20% for the Carabiner and for the Prusa part. So this print looks really good. There is a little bit of weirdness going on because these parts have some semi-full bridge or semi-bridging going on along the edges for a recessed nut or bolt, I believe. I'm not sure. Again, I don't have a Prusa. But I like the uniqueness of this part because it has a couple of screw holes or bolt holes, and it has a very interestingly designed area of the print here that has a thin wall, and then there's a recessed area, and of course there's 3 more bolt holes on the back in a vertical panel going up, which gives you a good idea of how well it does completing those little holes. So overall, I thought this was a good idea, and again, if you saw it on the close-up camera, you can see that it looks great, and I had no problems with printing this at 230 degrees. So let's go ahead and give it a little bit of a bend and see if I can snap off the support arm or support bar here. That's probably the weakest part, I'm guessing. So let's go ahead and give it a shot. Oh, no, I did break it in the middle though. So there is the weakness right there. Make sure I didn't cut myself. There is the weakness in that print. So I might actually have to move this up to 245 if I was to use this for any kind of machine part, because we certainly don't want that kind of breakage. Now it broke past, let's see if I can show you guys on camera where it did break. So it broke below that area I was just commenting that I thought was very interesting, and along the top part here where the print finishes up and going straight up, because I printed this with the bottom part here. I'm sorry, this is the bottom part, so the layers are going this way instead of this way. So it didn't really break near one of the screw holes, so I don't think that was a weak part. I think it was probably just some layer adhesion issues. So anyway, good test to see. This seems pretty strong with the layer going in that same direction, going this way on the carabiner, but if you, this strength is the strength for this lies in this part as well too, and the way this is set up, so that adds strength the way that's set up. So this I definitely would think about increasing the temperature should I use this filament for printer parts of any kind. But in general, this 100% recycled PET G printed on the sanded acrylic at 230 degrees gave us some excellent results as far as printability and quality. The strength, in my opinion, is, I think it's pretty strong. I wasn't able to break this, but I was able to snap this with a lot of effort. So that may have been enough to make sure that it is still strong, and I'm just strong enough to break this. But either way, I would definitely increase the temperature if I was going to use it for any kind of printer part. But any kind of other prints in general, I think you're safe around 230, and you can print it on the sanded acrylic or whatever smooth surface if you don't have a heated bed, which a lot of low budget printers don't have a heated bed on them. They have some sort of textured surface on them for bed adhesion help assistance. So overall, I think the PET G Natural printed out really great. So now let's move on to the Nylon 645 Black from Taulman 3D. Now, I'm really disappointed I could not get a successful print. All right, let's talk about the Cali Cat, because this is not the first print. This is actually the third print, and it did warp, which was a major issue. Layer bonding, this fell apart in my hands. So this was Cali Cat number 1. Let's see if I can put, he's just sad. I'm just going to put his head right next to him. That's Cali Cat number 1. I'm going to put my hand behind there for a minute so you guys can see a little bit of what that looks like. So basically what happened so basically what happens with my situation is that I don't have a heated enclosure for my G-Max 1.5 XT Plus, and I don't have a printer that has a heated enclosure. So sometimes testing certain filaments, I'm hoping for the best, because I can turn on the heated bed that I do have, and I have a floor heater that warms up this area of the garage. In the summer, it wouldn't be an issue because it's like 90 degrees in here. So it definitely, I have a built-in heated chamber by printing in the Las Vegas heat during the summer. But I don't have a heated chamber printer at all, and I knew I was not going to have any success. I printed with nylon before, this specific manufacturer. I printed with nylon before on another printer that did have a heated enclosure, but I no longer have that printer. But my experience was that if you don't have a heated enclosure, I know I've said that quite a few times now, you aren't going to get a successful print. Now, prove me wrong in the comments. If I'm incorrect, I'll be more than happy to take some feedback. But the specifics of this filament are 250 to 255 with a 45C bed, up to 75 millimeters per second, slower equals stronger, no fan. And it says print on glue stick, Gecko-Tech, or Garolite. So of course, I didn't even attempt the sanded acrylic. I moved directly to my Build-Tack surface on my heated glass bed on the G-Max. I just swapped out the 2 parts. It takes me about 20 minutes. And I went ahead and started printing right off the bat. And because I assumed it was going to work, because I always assume that. So I started the temperature at the bottom because we have a 5 temperature range difference, and 45C. So I went 250, 45C for this print. Now, again, it did warp, but that wasn't the main problem. As you can see, the head never finished because it pulled it up off the print bed because it got kind of gooey on the top. Now, I don't know if you can see that. Let me see if I can turn that. But it did get kind of gooey on there, and the nozzle just kind of stuck to it. So I saw it. I happened to be sitting here, and I started to drag around on the print bed, and I knew it was time to stop the print. So when I took it off, because it just kind of came off, it had already come loose, and I took it off the print head, This came apart like whoop, and there it was. It popped right off. That concerned me right off the bat. So I went ahead and kicked up the temperature to 260, which is 5 degrees over the recommended temperature. Now, I didn't think that would have much of a difference, considering that at 250, it was already warping and the layer adhesion was terrible. So the bed temperature was originally set at 45°C. I moved it up to 55°C, thinking that a little hotter should keep the plastic stuck a little longer. And this one warped off the print bed immediately. I didn't get far at all. I mean, it did its bridging, and it actually, the print looks really good too, and that's what stinks. It came off the print bed. It just as advertised, the filament is the concern, is their focus, not the pigment. So it is somewhat purpley looking and a little bit translucent. It's not 100% black, but that's not what they're going for. They're going for strength. And all those things happened. I mean, it looked great. And then one corner just peeled. I mean, I haven't touched the print since then, but you can see this corner right here peeled up. So I knew this was going to fail. So we moved up to a 60 degrees C on the bed, and I went up to 265. So it started great. It wasn't, I'm sure if I bend this, it's going to break, but it started great, and I didn't see any problems with it at all. It was printing along just fine, and once it got past the neck, I noticed it was starting to curl a little bit, just a little bit. So I let it go because I knew that the Magic Goo that I was also using as an assist for this, I should have added that in the beginning. I did use some Magic Goo for an assist on the bed adhesion just to make sure, hopefully it would stick down. And I have Build-Tack, and we're using heat. But it just, the Magic Goo held it in place. It wasn't the surface of the plastic that was holding it or the nylon that was holding it any longer. So up at the top, I felt like it was kind of moving just a little bit, just a little shudder to it. And it was, because the bottom had warped. So the top layers look really bad. They're really mushy, and the ears are all mushy too. There's no good surface quality whatsoever. So as soon as the print finished, I literally just kind of knocked it right over. So it was warped. It's definitely warped. So I'm guessing I need a heated enclosure. That's where the bottom line on this is. I do have other filaments in the testing phases that we are working with that do ask for a heated enclosure. I've had some success and I've had some failures. So I think it's the problem isn't the nylon filament. It's definitely my printer, because I just don't have that heated enclosure. So I can't really finish the testing on the nylon. I got one successful Cali Cat, but he still came loose and ended up giving me like the worst top layers I've ever seen. And I honestly, since we've already broken other parts on camera, let's go ahead and see how the layer strength is on this guy, if I can get a good grip on him. Oh, that's actually pretty good. That's actually really good. Okay, so now if we can solve the warping issue, we now have a really strong Cali Cat. But it's warping and it's not staying on the print bed. So my guess is heated enclosure. My experience printing with nylon is you need that heated enclosure to keep an ambient temperature around that filament to keep it somewhat molten in a sense and somewhat soft until you can finish the print. So we'll continue testing if we can figure out some sort of heated enclosure for this guy, or if I suddenly get a printer with a heated enclosure in it. I have quite a lot of nylon left. There's very little of the Petchy left. Again, you saw there was nothing at the Voracity left, and I do have a little bit of the eSilk. So we'll figure out something for the nylon 645. I'm really happy with the way that Cali Cat turned out. If it stuck to the bed, the top layers would look amazing, and you just saw a quick little strength test. It's really, really strong. I wanted to be able to print out a little spike and hammer it into a board and show how strong this filament is, but dang it, I could not get it to print. So we'll figure that out, and I'll do a separate video on that in the future once I acquire some of the Taulman filament. So overall, this was a really good learning experience, once again, with filaments, all kinds of different filaments. We had nylon, Petchy, we had Pro PLA, and we had some really cool decorative eSilk from eSun Filaments. So overall, the October MakerBox yielded some really fun filaments to play with. I'm really happy with all the results. We did some live strength tests so you could see how strong some of the filaments are. Definitely have to make some adjustments if I was going to print them for certain kind of mechanical parts. But as far as the decorative prints look, they look amazing. I'm super happy with the results. The nylon has left me sad because I really wanted to have an on-camera nail in the board test so you guys could see just how strong this filament is. So we'll figure that out in the future, but for now, I think we're wrapped up. I'm super happy with this month's selection of filaments. If you're looking for a really cool subscription service that gives you different levels of, this is the middle, I believe it's the Explorer, so it gives you 4 sets of filaments, 4 separate filament samples, plus you get some stickers, some sort of 3D printing item of some sort at certain months, and of course some candy to chew on. So this is a really great month. I'm really happy with the results. If you want to subscribe, check out the subscription service link down in the description, and that'll give you all the information on how you can get your own MakerBox monthly subscription service. Again, we weren't compensated in any way for this video or for our opinions or for us doing any of this testing. Obviously, we're just doing testing, so the only thing left over is the prints. I hope you guys found this episode interesting and informative, and if you're looking for ways to support the channel, check out those affiliate links and all the other ways you can support the channel down in the description. And of course, don't forget to subscribe to the channel, comment, like, and share those videos, and I'll talk to you guys soon.